Alright, so here's the third video, and our such a question is how can you use the elimination method to solve a linear system? And I saved this one for last because this is my favorite one. And it says it's pretty much what the name is. You're trying to eliminate variables. Alright, so here's our first example. Use the elimination method to find a solution to the following system of equations. And I went straight into a hard example, just letting you know, just a heads up, because I want to be able to show you the different procedures that go on in this. So usually in the elimination method, you have these two equations, you write them up, and you're gonna do something that looks like plus equals blah 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 blah. You want to get it so that when you add them, either this variable cancels or this variable cancels. And by that, what I mean by that is, let me close this. What can you multiply by first equation? What can you multiply in the first equation to get it to cancel to the second one? Think about it. By that I mean, what can I multiply this whole top equation so that when I add them, just like I did right now, you get either 0 over here or 0 over here. Well, if you know what you mean, because I know that was kind of confusing, let's give it a shot. So what if I multiplied this first equation, multiply the whole thing by -2? If you distribute it in, -2 times 3x is -6x. -2 times -7, remember negative times a negative is a positive, so it's positive 14y, equals -2 times 10, which is -20. Now this other equation, I'm just going to rewrite it, so I'm going to keep it the same color because it's still the original one. This one over here would be like 1 star because it's special. Because it's still the same equation, but we rewrote it. So this one would be 6x minus 8y equals 8. Now here's the really cool part. Here's what I was trying to get to in the beginning. When you add these two, you're going to get 0 over here. You can say 0x, but I'm just going to say 0. Remember, it's not x because -6x plus 6x is 0. So now when you add these over here, 14y plus -8y or 14y minus 8y, you're going to get something like 6y. So plus 6y. And again, -20 plus 8, you're going to get -12. This is super similar to what we've been doing in the past, so all you have to do is divide by 6. Divide by 6. Y equals -2. So we're kind of done. We found one of the y. Let me put this in purple. Let me scoot back a little bit. The third step, which is pretty much what we've been doing in all the other ones, is substitute it back into one of the original equations. And for the purpose of making this an easy problem, I'm going to put it into the first one. So let me write down the first one again. And our original equation, remember you always want to use the original equation, is 3x minus 7y equals 10. Now, we know y equals -2, so you can just plug that in over there. So you get 3x minus 7 times -2. Remember, this is this new y that we just found, equals 10. 3x minus 7 times -2 is positive 14 equals 10. Subtract 14, 3x equals -4. Scoop that up a little bit more. Divided by 3, x equals -4 over 3. So here's our second solution. So what does that mean? Let's bring this over here, let's bring this over here. That means that our final solution is x -4 over 3, comma -2. That is our final solution. Remember, the final step would always be to plug those in and check your work for both equations. So in other words, these two lines are going to intersect at x equals -4 over 3 and y equals -2. So stay tuned for the next video. In the next video, I'm going to show you a different example that's going to be a little bit more complicated. And always remember that I'm giving you the guided notes online. So if you need the actual notes, if you want to rather just look at the PDF, go ahead and do that on your own time.